Oh, good morning, everyone. Welcome back to the Daily Grind. So, for those of you that are joining us for the first time, this is a very informal chat over a cup of coffee about shop culture and machine shop practices. The other side of that, being the double entendre, is coffee. So, as you guys know, I caught up with a fellow alumni from Penn College in Williamsport, and they were very kind to offer me a sponsorship. So, be sure you check out Fresh Roasted Coffee. Links in the description. Be sure to check them out. And then you guys can see we're back in the Formula Garage. So we had work going on in the shop this morning, right at the first thing. So the car team was nice enough to offer us their spot. And if you guys look with me, we have our second or third in-person guest. So this is Dr. Steve Kurtz. You're the doctor, right?
I am indeed.
Oh, yeah, my goodness. Ph.D. type Dr. Steve Kurtz.
Yeah, I can't prescribe any prescriptions.
He is a professor of civil engineering. Speaking of engineering, if you or someone you know has somebody or a high schooler looking for a place that's going to put them ahead of the pack when it comes to engineering, be sure you join Lafayette and say Colonel, or why not? So, let's make our first cut. Let's hop right into the interview. So, as with all my guests, brief backstory. Who are you? What do you do for Lafayette? Please take the stage.
My name is Steve Kurtz. I'm a civil engineering professor. My specialty is in structural engineering. So we are the people who are concerned with steel and concrete and making sure that structures, buildings, bridges, etc. Don't fall down. I've been at Lafayette for 24 years. And I've loved being at Lafayette College.
Good deal. So, another shameless plug for engineering. What would you say that, especially in civil engineering side of the building, what puts us ahead of the pack for everybody else?
Well, I think there's no question that it's the hands-on education. I would go as far as to say that I don't think we really have education if it's not hands-on. We learn with our hands as much as we learn with our eyes. And so what we're able to do at Lafayette is stuff that is very difficult to do elsewhere. And maybe if we could cue up that little video of the kinds of things that we're able to do. We've got the CE 311 bridge competition as an example.
Yep. So let's
right there. We'll show that one. So this is an example of what we do.
So this is the machine itself.
So to make a cut to a particular dimension,
Dr. Kurtz,
I'm going to loosen it up. You don't have to pull this vise back. I did that earlier as a demonstration. You would rotate it and pull it. There's not a need to do that because the piece slides freely now. I'm just going to slide that thing forward, and initially I'm going to use a ruler in order to take my measurement. Now in metalworking, we always take our measurements right off of the cutting tool because it's the most accurate way of doing it. In other words, we're not going to bother to put some kind of mark on it here because the mark would be thicker and less accurate than that blade. So suppose I'm looking for a particular dimension. Suppose I decide I'm going to make a cut at 4 5/16.
All right, let's play this one.
Here
we go.
This is a really good example.
To see real well.
We can do.
But I would
done all the design work for me.
That's looking pretty good. 4 5/16.
Has to fit inside a 42-inch box. They design the bridge. They fabricate the bridge. They compete with this bridge. I'll talk a little bit more about bridge competitions in general. But this kind of thing that we've got, this is 8 students in a lab section working together with their hands to build 30 to 40 parts on a bridge that then assembles and ultimately gets loaded with an awful lot of steel.
How much weight we talking? Because I never really knew.
This competition right here is my in-class competition. So we put 3,600 pounds of load on
Whoa.
this thing. So, and they mostly pass the load test. Sometimes they don't. Right? There's nothing wrong with that. We got to learn. We got to learn by doing, and I think that's really what this is all about.
So there was a pointer that you had, you and I had spoken about briefly, is the learning from failure. So to give a slight example to the audience is we used to have the SAE aeroplane. Remember Lou Hayden?
Sure, do
right.
remember
So
Lou,
he's in the room right behind. He was in the room right behind you. He headed that, and him and I would almost beat our heads against a wall trying to tell the students, fail here, do it, run that damn plane. Because if you fail here, you can find out what you did wrong.
Yep.
And nobody's going to judge you for it.
What I say to the students in this is class that every civil engineering student takes. So I think that's an important thing here. These are not particular kids. These are every kid in civil engineering does this.
Yes.
Right? This is, everybody does it. And I tell them, and they're competing against one another in this competition, and it matters an awful lot to them. And I think that's what's important about this. But I tell them all the time, I'm not rooting for you. I'm not rooting against you. I'm going to keep you in the playing field. Right?
Okay.
In terms of engineering knowledge, that's what I'm here to do. I'm an educator, so naturally I'm going to be pretty knowledgeable about structural analysis and steel design and how to do the CAD work and how to do the detailing. And I'm pretty knowledgeable about fabrication.
Yep.
Right, so I can help with all of those things, but I'm not rooting for you, and I'm not rooting against you. And so that means that there's a lot of times they're doing things I know are not good ideas, but you got to let them happen.
Yep, and that's something I always fought with, was as a fellow educator of sorts. I mean, I'm not a professor by any means, but when I'm
You're
working
working with kids all the time.
all the time. But when you know that they're going to fall on their face, especially as sophomores and underclassmen, you want to kind of just and insulate them, but you also have to let them go. And now more as seniors, I will let them walk right into a wall. I've come to the point where they should know better.
Yep.
When it comes to design and basic things, so I will let them trip up.
Sure.
And then explain to them, well, let's look at this.
I mean, one of my policies is that I'll say that I am not going to go out of my way to tell you that your design concept maybe is flawed.
Okay.
Right? But I'll answer any question.
Well,
And that's the thing, is that you've got to then get people who are going to constantly pepper you with questions about what they're doing and whether these ideas are good. I'm going to tell you my honest opinion on things. You got to come out and ask the right questions, and then I'll tell you what I think.
Oh my goodness. There's another professor here, Dr. Hummel, who had said one time, if you don't want an opinion, don't ask Rob.
Yeah, no, I'll give the opinion. That's for
Oh
sure.
my goodness.
So, I guess we're still kind of talking about background and
Oh, yes,
so
yes,
forth,
yes, please.
And so I've been an advisor for what's called the National Student Steel Bridge Competition for 30 years now. So I've advised it for 24 years now in Lafayette. But actually, the first thing I said to students when I first came here 24 years ago was, this is what I'm about, all right? And so I've been advising it as a graduate student going back to '96.
Wow.
And the National Student Steel Bridge Competition, I think we'll probably show a little clip so people have an idea about that if we can.
Yep.
If time
So
permits. A
let's-
good one is if you could pull up that 2019 competition. You pull that one up. That's
let's see, where it would be under what?
a steel bridge competition.
19, you say?
19's a real nice one.
Okay.
Yeah, we won nationals that year. And so with all due respect to any other engineering competition, I think this is the best engineering competition there is. The reason I think this is the best engineering competition there is that this is an engineering competition where every year the rules are completely different.
Yes.
You know, so this is like if
We
you...
in the shop know very well.
Yeah, if you... Let's suppose you're on a baseball team and you're real good at baseball. Well, guess what? Next year we're wrestling. All right?
Oh, that's a big difference.
All right,
That's a big difference.
That's what it's like. It's
Yeah.
night and day. You cannot rely upon what you did last year. And so what you're seeing in the video right now is also a very simple competition. This is a competition with 3 measurables. How fast can you build it? That's one of the measurables.
Okay.
These kids are assembling this bridge over a mock river that they can't cross. They're going to build it in about 3 minutes and 15 seconds. And actually, they're fully bolted up within, I think, 2 minutes or so. I mean,
Oh,
they
my
get to the
goodness, look
bolting
at
in
this
about
go.
2 minutes. That's one measurable. How fast can you assemble this bridge? Number 2, how much does it deflect under a 2,500-pound load that's randomly placed? So 2,500 pounds of load is applied to this thing. You want it to deflect as little as possible. There's cost for every inch of deflection, right? So depends on the year, depends on the rules, but it might be $4 million per inch or something like that. And then the third measurable is how much the bridge weighs.
Yes.
So if every pound that your bridge weighs has a cost. So there are only 3 measurables, but it doesn't take a lot to change in these rules to fundamentally change what the gain.
Yes.
Right? So there have been years in which the cost of the weight of the bridge was extremely high.
Yeah.
So what does that do? That drives your bridge to be extremely light, excessively light, crazy light. You can't believe how light people are able to get if
Yeah.
that's what the rules are. We've had rules in which it was the opposite. So that keeps students on their toes too, right? The ideal bridge was actually extremely heavy.
Okay.
You got to do your math, right? You got to do the analysis.
Yes.
The rules have to be interpreted and understood by the students. And so that particular year, 2019, I think they're finishing up right there. We won nationals by a good margin. It's been a few years since we won nationals, but we're always very competitive with it. The game changes every year.
I mean, Steve, let's be completely blunt. When you say you haven't won nationals, what place did you come in?
Well, we were second place last year.
We were second place last year. You're taking up the end of the.
It's a great group of kids.
Yeah.
Second place in a very competitive competition. About 250 schools compete nationally every year.
Wow.
Right, and so we have not been outside the top 5 in 12 years now.
That's
We're
wonderful.
always in the top 5. We expect to be. That's the way.
So this is more for me. Is when you say you were dead, you're like really close. And who was it? Are you allowed to name drop?
Who the winning team was?
Yeah.
Oh, I'd rather not say.
Okay. No. It's a swear word.
Hey, they're a very good school. We respect the heck out of them, of course. But you know what, Rob? We're not going to say that.
That's fine. So, what was the time difference, or what was the final score difference? Was it like red hair clothes, or was it?
A couple of years. This past year, I'll tell you, they beat us pretty well.
Okay. All right.
We had a year in which we lost to that particular school by 7 seconds. That was pretty close.
Okay.
7 seconds of build time. There have been some close ones. This past year, look, you got to compliment the people who are better than you.
Oh yeah.
Right? You have to. Doesn't mean you got to say their name though.
And be nice to them. You have to respect them.
We're nice to them. We respect them. They respect us. But
Yeah.
here's the thing: we got to beat them.
So
We got to beat them.
another thing I've raved about of Lafayette for a lot of our civil engineering programs, the underdog syndrome. We have smaller shops, we have smaller facilities,
Right.
but I mean, we're one of the few schools that I think that have the full-fledged shop support.
You guys, the machinists at Lafayette are the best.
Oh, please go on.
You guys, you're the absolute best, and I think we'll probably talk about it a little bit later on. But a big part of why we've been able to be successful is that there's a natural back and forth that has to happen between that student's idea and you guys helping us make it happen.
Oh, yeah.
And we've got what is great about the way we operate is you listen to us, we listen to you, we understand that the ideas are still just developing. You guys understand maybe what can be done and how it can be done different, better. And some of the best things we've done in recent years happened, and I have to say, well, it wasn't just done by one person, right?
Oh, no.
It wasn't done by one student or even the students, right? It was that conversation that we had to have with you guys.
So you have some samples here. This I'm ready for. So
You're ready for it.
We've talked about, and I actually covered in September, I believe, of this year. I have an article on face milling, and I use face milling for this connector. So if we take
This
the
guy
quarter,
right here.
take
Yeah.
that quarter turn apart for me.
Well, I think we got to get the
We
view
got to
right
get it in
there.
the view.
I don't
So
know if
that's
you can
the
see that right there.
connected view, everybody.
Now, the kid who originally came up with this idea, he called it a lozenge connection. So you can see I'm turning it right now. When I turn it, boop, pops right apart. And
That
so,
face.
very, very enigmatic looking connector.
Yes.
Got right there. And of course, the machining on this is real tight, real nice, but still, with just the right lubricant, these things come apart super quick, which for us, see, you saw in the video, that's one of the things that matters an awful lot to us, is how quickly can we put this thing together and take it apart.
Oh man.
Other thing, very important as well, is just how stiff this connection is.
Yes.
Right? The
Yep.
stiffness is extremely important to
For
us.
how thin the wall is and how
Yeah.
long the piece is.
And I think we'll probably delve into it. Of course, the way things work around here is on our end, we are fabricators. You guys are machinists.
Right.
So you produce for us, perfect work. And then when we fabricate, we got to make sure that when we put this thing together, we don't distort it, ruin it and everything fits up properly. And that for us, that's our challenge.
Right.
Is to take something that you guys make that's perfect and then manage to hopefully have it not distort on us in a way that compromises it.
So to take a quick step backwards, if we remember, this month's topic is sawing, and I know having a professor of civil engineering on is not calculating for some, but if we go into how much sawing you guys do.
Yeah, you hear our machine running all the time,
Oh
right?
my goodness, it's
Just
before we
running
get here
all
and
the
after
time.
we leave.
Yeah. So I guess the first thing I have to say, Rob, is that I'm not paid by Marvel. It's not an endorsement or anything like that. But we've got a Marvel Mark II Series 8 bandsaw, and I'm sure a lot of your viewers are familiar with that saw. Maybe a lot of them aren't as well. It's an absolutely beautiful saw. I love this thing.
So this is the machine in Dr.
Yeah.
Kurtz's civil lab. So this is top to bottom. He covers in the video and in our talks. We've covered all of the features this thing has. But if you look at this vise,
When you look at a piece of equipment like this, you know that it's quality, because I'll tell you, I've seen versions of this machine that are 60 years old, and they haven't had to re-engineer anything.
Yes.
In this. That vise is perfect. That vise just perfectly slides inside that T-slot. So when you squeeze it, it doesn't budge.
bites real well.
It
So
bites really well.
if we look at that thing, it's got a gigantic 45-degree bevel on it. So that brings us to the next point of this saw. So
Yeah, so this is a tilt frame bandsaw, and what the tilt frame means is right now you're looking, I'm just showing, using a tape measure to measure the length of a part, but right in the background you've got the band itself is typically vertical, but it will tilt plus or minus 45 degrees.
Wow.
And then it's going to auto feed, so you fix the piece to that vise on the T-slot table.
Yeah.
And then it is the tilt frame, right? The actual band and the wheels, all right? Those things are being auto-fed.
Yep.
Real fine control on the force that you put on there.
yeah, counterweighted control, isn't it?
It is.
Yeah.
It's beautiful. Because a lot of saws, what they're going to do is they're going to have their feed is going to be a screw drive of some kind that is
Yep.
going to apply like a constant speed.
Yeah.
Now, you do much better with the blade with this machine because you're applying a constant force.
Yes.
Right, with that constant force, and we go real light with it. The blades last forever, and it's real accurate. Now, what we've done with the machine, which I think most people probably do with a machine like this, is that I think you'll see shortly we've got a ruler built into the table.
Right here, yep.
Got these side tables, and those were just built here. I built those right after we got the machine. You level the machine, make it perfectly leveled, and then you bolt those side tables, and then with a real heavy-duty stop,
Oh my goodness, look at
right?
that thing.
It's a heavy-duty stop. We got an adjustable pointer on there because, like you said, we trust but verify.
Yes.
So that thing is accurate, but you can always adjust that pointer, right? So that every cut ought to be within a 30-second, right? Is what we
Right.
kind of expect it should be. But you can achieve that because you have a high-quality vise. You've got that ruler mounted to the table with a very stocky, heavy-duty stop.
Yeah, it is.
So for the production work, and so Rob, you're asking why is that thing running all the time? So we got all of our lab sections with junior level students who are cutting all the time.
Yes.
We got our steel bridge team. That's a separate thing. These are the national competing people. These are seniors,
Yep.
right? And they can be in there day and night. And there are hundreds of cuts that are involved in the production of one of these bridges.
Speaking of that day and night, I've talked about this many times on the show, is, our college offering one of the only programs, like you said, that puts you hands-on.
Oh yeah.
And this is the only way to get it done. Is
That's right.
All of this work. So the production sawing part of it, we talked about now. I cover in my article from March a couple other types. And I said this last episode too, and I'll say it again because I'm sure I forgot something, is I misquoted. I actually put a wrong type of saw. I only ever used a cold saw like once, and they're slow RPM sawtooth.
Sure, yeah.
But I thought that was a chop saw.
Oh
The rubber
those-
reinforcement.
Yeah,
Right.
those are different.
So,
we used to have a real nice cold saw, but we no longer needed it, and our space is limited. So when we got this tilt frame saw, we got rid of our cold saw.
So and they're very niche market, those things.
They are.
If you have need for it, great. But if have no space or really have a better machine,
Yeah.
it's the way to go.
Yeah.
And I know you're not a shill for Marvel, but this thing, I've used it a few times, and I'm a
It's
huge
wonderful.
fan.
No, the ultimate proof of an engineered product is if 60 years later you're still making it the exact same way. And when I first used this saw, that was years ago. It was University of Missouri. That's before I was at Lafayette.
You had a Marvel?
We had a Marvel
Okay.
from the 1960s.
Yeah.
And it's the same machine.
Wow.
It's the exact same machine. And I knew, I had never seen anything like it. It's so well built that when I got the opportunity at Lafayette to convince people that we needed a good saw, there was no question that you're getting a Marvel.
So, if you remember, I had a company that you helped us with, Scotchman.
Oh yeah, no Scott.
I had them
They
on
make
the
great quality stuff.
They do. Oh my goodness! And if you ever watch the episode, if you guys watch the back episode, their rep, that Brad Kuchenbecker, fantastic. And the stuff they're coming out with now is worlds and a bound more than what even those things. That iron worker and that horizontal saw we have
Yeah.
are old potatoes.
Right.
And the stuff they have coming out now is just mind-boggling. So cool.
Well, it's great when you come out with new stuff, of course. At the same time, when you've got a piece of equipment that after all these years doesn't even need to get better.
Right,
That's,
if it ain't
that's a
broke-
quality piece of equipment
If
right
it ain't
there.
broke, don't fix it. So
Yep.
we have a big bend, a big 45 degree coming up
Yeah,
now.
so it
looks
can
like.
tilt plus or minus 45 degrees real easily.
Yeah.
It's got the protractor built into it, of course. We use a digital inclinometer just because it's a little quicker.
I was
easier
gonna
to
say.
read, but it's the same thing. And for production work, when the beauty with this machine is that when you turn it 45 degrees, that doesn't change the length of anything, right? Your stops still work because that blade is dead on at table level.
Right, that's the pivot point.
Right, that's the pivot point, and it's real accurate. So you can set your stops. You can do 100 parts. You can do any angle you want, plus or minus 45. And we'll talk a little bit. What do you do when you're beyond plus or minus 45?
Yeah.
Production work plus or minus 45 is real good. We've got ways to be able to do production work with great precision and speed, and go sharper than 45
So
degrees.
that brings up the question: do you guys have custom jigs? Has the shop ever made you a custom jig?
Oh, you guys make us all kinds of great stuff. Yeah, you do. But when it comes to this saw, when we need to do anything sharper than 45 degrees, one of the things you can do is you can always just fixture to that T-slot table. Right, you got that T-slot table. You can fixture something at any angle you want.
Yes.
Right.
Yep.
You can even do compound angles
Yes.
with that thing, and we have.
Let's see, do we
and
have
maybe show
one?
I have the video. You can rip.
That's the
That one we
45,
can
right?
show, we can show that one. Maybe we'll show the ripping one first because unless you want to.
That's
go
a
with
picture. So let's see. There we go.
the rip.
So nope, this is and what angle is this? Is it full 45?
So yeah, what are we looking at right there?
Oh.
Okay, so that's okay. I'll talk about that a little
Yep.
bit. Okay, so you would say if you've used the saw a little bit, maybe you'd say, well, it's wonderful for production work up to plus or minus 45
Yeah.
because you just clamp it in there, get your angle. It's definitely accurate to a degree for sure.
Yeah.
You can get to the degree, no problem. Set your stops, cut dozens of pieces. It'll work really well. But what are you going to do when you're sharper than 45? Well, when you're sharper than 45, you could fixture it horizontally on the T-slot table,
Yeah.
or you can do what you see in that video right there, which is real simple. We just have, maybe you pull that video back up again. That would be
This one.
All that is, look, we just cut a piece of cold finished half inch.
Yeah.
We have a bunch of these things. They're cut. What do we cut them at? We cut them at 30 degrees because then what you do is you can stand, if they're relatively short parts, you can stand the parts up in the vise. And like I said, if you've got a high quality vise, which is what we've got right there,
Yeah.
then what we can do is you turn that tilt frame to 45 degrees. The part's been stood up 30 degrees. Now you can go plus or minus 75.
Wow.
Real quick, right? And so like this past
So quick.
Right, this past month, the students were cutting tons of most of their bridge are these sharp parts. Well, you need accuracy, you need precision. You also need speed, though.
Yep.
Right. So you need to be able to set the stop, and the accuracy on those things, I think I told you before, is like bolts are just dropping on yourself. Wait, because if you cut everything accurate, everything else kind of falls into place for you.
Yeah. So this one we have. I call it the Ripper.
Yeah.
So this is another like custom thing, or what are you doing here?
Well, so I think probably most of your viewers, maybe all your viewers, are familiar with a conventional vertical bandsaw.
Yeah.
Right. So we'll use. Too.
It's like your version of a table saw.
You could. It's got such versatility.
Oh,
you can
man.
use it like a table saw for metal. Now, mostly what we deal with is relatively light gauge. We're doing 16 gauge hollow tubes and so forth. So it's not like the force is real high.
No.
But if you had thicker material, no problem. You would just clamp it and use the auto feed.
Yeah.
Right.
Yep,
So you're not hand pushing it. But for us, a lot of times, hand pushing like 16 gauge hollow tubes is no problem.
So that brings up two questions. I see you have another sample, the can.
Yeah.
So as much as you're at liberty to discuss this without giving away ghosts.
Oh, I can.
This is one of those things you ripped?
Oh yeah, this was ripped many times. So I'll show you a few things about this. First of all, it's an example of the machinists do beautiful work. So this, I'll call it the full circle. I'll see if I can break these apart.
Go for it.
A little bit. So you can see that these things fit nice and snug. Now, how does that happen? So, machine shop turned this part, and it turned that part until it was just a perfect dead-on, about 1/1000th of an inch clearance with the outside part. Now, I'm sure a lot of your viewers know that if I take this outside part and I go and rip it, of course, the residual stresses inside are completely mess it up. It won't fit anymore at all. So what we do is we stress relieve it for, we went about 72 hours, real slow, take it to about 1300 Fahrenheit in a furnace.
Yep.
Real slow, bring it down real slow. Then when you cut it, nothing moves.
Yep.
And it still fits perfect, right?
So you heat treated before we cut it?
Well,
I don't think I was involved in the cans.
Yeah, no, I think, the turning work, everything gets heat, stress relieved.
Yeah.
Right?
Yep.
And we just make sure that we stress relieve it. You know what? We stress relieve these before they were turned.
Okay. Again, I don't think I had a hand on the cans.
We might have done both.
Well, you might want to do both.
Before and after.
Yeah.
So anyway, then we have all of these cuts that we got to make, right? Like that's not the kind of thing you're going to do on a horizontal bandsaw.
Nope.
But on this Marvel, I mean, no problem to rip apart like that. So they fit up, and I think we might show in a couple of minutes like what we're actually doing with this.
Sure. So the blade choice.
Oh yeah.
So when I did my article, I went through the typical basic stuff you see in the machinery's handbook. Always have 3 teeth engaged. If you're doing harder stuff, do fine teeth, soft stuff.
Of course. And I read all that.
Yeah.
But the problem is, if you went by those guidelines, I don't know if there are blades that they make for doing the light gauge material.
Right.
That we deal with. But I have found that just 14 teeth per inch, so it's relatively fine.
Yes.
And with a light enough feed, no problem. We get blade life of at least a year out of these blades.
For as much as you use it?
Right. And part of it is I think that Marvel saw with the way it auto feeds, it's very gentle in the blade. So like getting enough teeth per inch, you got to have that. Right, and you can't have too many. Like if you're using a blade like that on solid, thick material, that's not the right blade.
Correct.
Right.
Yeah.
But I think the more important thing, I don't think brand has. I've never found a brand that they're all pretty good.
Oh sure, yeah.
Starrett, Lennox, Irwin. I've used them all. They're all good.
Sure.
I don't have any particular problem with that. You got to hone the blade. That's a big thing.
Hugely important.
So,
don't throw it on and use it right away.
I did replace a blade last week, and I have to tell the students, okay, this thing's hands off for a little while because what I'm gonna do is I'm gonna cut through a lot of solid stock, real slow, real light feed,
Yep.
because you got to get those teeth honed. And I assume everybody knows what that means, but just in case, any sharp cutting instrument, doesn't matter if it's a knife or if it's a hole saw or or a bandsaw, what you want to do is just slightly blunt those sharp teeth.
Yep.
Because if you don't, then you're going to pay for it. It's going to, it becomes like it'll break the teeth, it'll ruin the teeth.
Grab too much.
It'll grab too much, right?
Yep.
So you got to do that. And I'll very slowly, anytime I change that blade, just run it through a lot of solid style, get a very light feed. For a while, I don't even tell the students this, I keep the feed extra light.
Yes.
So when they start to go on that light gauge material, if you only have 14 teeth per inch, that could be abusive to those teeth.
Yes.
Right. But you go with a nice
impact.
light. Yeah, exactly. Yeah. But if you go with a nice light feed the whole time, whether we're never because once you start to knock a couple of teeth off a bandsaw blade, you're done. Right?
Oh, my goodness.
The blade's done. Right. You have to kind of maintain it. And,
My audience knows my trials and tribulations with stainless, and we cut a lot of solid stainless. Professor Toby Rossman, when he was building a lot of his research equipment, I think that's all we cut for a while was solid stainless. And
Right.
you lose one tooth in solid stainless,
you're done.
it just digs into the material and then work hardens, and then you're fighting yourself. Oh my goodness, I could go on and on. It's just
The only
nightmares.
the only thing you can do is just make sure that the blade's good all the time.
Yep.
Right. And so you start by honing it properly, take your time with it, and I'll cut through, I'd probably spend an hour or so just cutting solid stock just to make sure that blade is ready for the students to use.
And so, not to foreshadow too much, but I have another written piece. I forget what month. Tool sharpening. I think it's November. It's tool sharpening, and I go through drills. Drills are the worst because if you sharpen a drill, it's just like a razor blade.
Yep.
And you have to strop the two cutting edges
Right.
to slightly dull them. So we use a piece of hardwood.
Mm-hmm.
And if you ever use like a maple or oak or something, it just breaks that little rolled off edge
Nice.
perfectly. And now it's only two cutting teeth, unlike a saw, which is how many tiny, thousands of teeth on a blade.
Exact same principle.
Yes.
Right. Same
You
principle.
strop the end of the tooth, just like a barber does with the razor.
Sure. Yep.
So, excellent. So my next question for you is, how did you decide to acquire that machine? What was the process for coming up with it?
Yeah.
You make saw cuts, but how much of it's used for like weld prep? Why did that
Right.
come into the?
Yeah, no, because it may not necessarily be the perfect saw for everyone, especially because it's not cheap.
Yeah.
Right. This is not an inexpensive saw.
Right.
But I had mentioned that before I was at Lafayette, so this is going back 25 plus years. I was at University of Missouri, and we had a 1960s Marvel that I just thought was an amazingly versatile machine for at least this kind of fabrication.
Yeah.
Okay, so, and I think it's a great saw for many kinds of fabrication, but look, if you are doing angles a lot, then it's a great saw for that.
Yeah.
If you are doing generally production work, it's great for production work of a certain size. It may not be a saw that is worth the money for you if you are cutting, just 90-degree kind of stuff all the
Yeah.
time. If maybe you're not doing this kind of work, like the versatility of it. Being able to do something like this, knowing that you can.
So that's what
Right.
sold you, is the versatility.
Oh yeah. The fact that you can do all the usual things,
Yes.
right? And you can do that with great productivity. But sometimes you got to do this, and I'll just tell the students, we'll find a way, right? We can find a way to do this, and you just wouldn't be able to do that with a convention. We replaced a perfectly good horizontal Kalamazoo saw.
Yes, I
That's
remember the Kalamazoo. Oh my goodness, that's going back.
Perfectly acceptable saw, but look, what are you going to do with that saw? Your accuracy with the stops is lower.
Yes.
It just is.
No, let's be real.
The stops are a little floppy, and when you had parts of a certain length, you didn't really have a good way of getting speed with accuracy and precision. Wasn't real great angles. You're going to get out a protractor and stuff like this, and if you need to, and you're certainly not doing work like this with it.
That's right.
Right. So I think that when Lafayette decided, okay, we're going to get a new saw down here. At first, Lafayette was looking at regular horizontal bands.
Sure.
And I just was fortunate that people understood that if you could do more with it, that we would make great use of it.
Yeah.
You know, and we certainly do. And as you said, Rob, the thing is running all the time.
Yeah,
it's
it is.
just a constant noise in this building is hearing that saw running.
Oh man. So you have another sample here. I think we called this one the lollipop and the T-slot.
Oh, yeah.
So this is the one I wanted to focus on for the sawing aspect of it. So if you look, there's a male and a female. And when Dr. Kurtz and his students sent us the blanks with their saw, they cut it off. What you see there is a joined piece plus some extra, so we had something to grip on.
Yeah.
So we actually made them as matched sets. But for the audience and the sake of sawing for this month, this was another production job. I can't remember. I think we had 50 of that size,
Probably.
50 of another size.
Yeah, we give you so many of these when we were running.
There, when he says his saw ran day and night, I mean, we would show up the next day in a cart.
Just a cart full of parts.
Of steel.
Especially, the 2020 team, we probably gave you guys 8, 9 different varieties, right?
So it was the same but different, and it was enough different that it was a whole other setup.
Theme, new setup though.
Oh my goodness, I cannot
Yeah.
tell you how much time I spent making tiny changes to get the same part of a different size.
Yep.
That was a big fun year.
Yeah, no,
I know it was.
These things are an awful lot of fun. This particular one was, this is 2021. That was COVID year.
Yep.
And I know that because these are extra heavy, and the rules that year made them extra heavy for us.
So that was one of the years that weight was less of a factor.
Basically, what happened because of COVID, they couldn't have a real competition, right? So
Yeah.
they had this virtual competition. Well, the thing about a virtual competition is certain things can be verified by camera. You know,
Yes.
that your bridge passed a load test.
Yeah.
Right? But they can't really trust that people can measure to the thousandth of an inch the deflection of a bridge. Like you can't trust that.
Yeah. So what did you? What dial indicator?
Basically, what they did is they said that the deflections didn't matter. It just had to pass the load test. So we ended up with a bridge design that I'd call it kind of a caveman design. What did we need to do? We need to build a bridge with 3 people in 2 minutes.
Yeah.
Right? And have it survive a load test on camera. But the deflections didn't matter.
Okay.
And it was a very simple bridge. It was a simple bridge with very big forces on it that led to very, very big connectors.
Those are boat anchors.
They
compared to the
are.
other
These
ones.
things, I mean, relative to the other ones we have, some of these things are extremely light. You know, like the wall thickness on this guy.
Yeah.
That's like 0.35.
That it was very little to grip on.
Yeah.
Now, so speaking of teams, I just remember this now is the 19 team. Is that the bridge that hangs above the third
It
floor?
is, yeah.
So, if any of you ever visit Lafayette, or if you guys are Lafayette alums yourself, when you come in the front door on the 3rd floor, Dr. Kurtz's 2019 team has a bridge that hangs above the door
And
as a
the
memento.
2018 as well. They're both up there.
Is that the red one?
Yeah, they're kind of laced inside each other.
I didn't know
That's what I
that.
did. The question was when we were going to put the national championship up in the rafters,
Yeah.
literally.
Yeah.
And then the question was, well, what do we do when we win again? I said, I'll figure out a way to put them both up there. And
so
if
cool.
we keep on winning, we have to put more of them up there.
Yeah.
And a challenge because they're pretty high in the air, and you have to climb up there, get some scaffolding to build these bridges up in the.
Yeah, in that foyer, yeah.
Yeah.
So I want to address the damp element in the room. So you see Dr. Kurtz laughing. This is something, and I've made mention of this in the social media post before, is let's talk wet sock.
Yeah. So we call it the wet sock technique, and I think a good illustration of it is this connection's probably a good example.
So we have
Yes.
Yes.
So I'll tell you what's happening. Welding knows that metallurgically speaking, quenching something that you welded is a terrible idea.
Yeah.
Like you should never do that. But we have situations where we have parts that, first of all, when we're done machining and doing that furnace work on them, man, they fit perfectly.
That is
fit perfect, right?
Dumb perfect fit.
And the only thing you can do to it as a welder is ruin it. Right? That's the only thing we can do to this thing is ruin it. But a lot of things have to get connected to this. And I think we may have a picture we can show. We've got tubing that has to get welded here. We got cover plates here and here. We got cover plates on the back. So we got cover plates all over the place. Now, if you put something like that together with welding, you're just going to distort it and ruin all of that perfect fit. So,
Yeah.
I think I have it under that wet sock directory.
All right, let's see. We have just the video.
Oh, just the video?
But
That's fun. Oh, you know where it was? It must have been under the, where do I have it? I put it underneath that Marvel bandsaw, I think.
there is.
Marvel bandsaw, that can connection. Can connection 1 is not a bad view. Oh, that, it's actually just a JPEG. Can connection
Okay, then
1.
I don't think I have that one yet, but
Under Marvel, but that's fine. That's
Yeah.
fine. I can describe the thing quite
Yeah.
adequately. So, in a nutshell, what we have found over the years is that when we have something that's been machined and it's perfect, and you want to not ruin it, but we got to weld on cover plates here. We got to weld on a tube here.
it just hurts to listen to.
We wrap the whole thing in a literal wet sock, okay? and we will get, and this is terrible, from a metallurgical standpoint, you know it's bad, but all we're looking to do is just blast it with a little bitty weld, and then immediately blast it with compressed air and more cold.
Yeah.
Now, why is that? Like, the thing about weld distortion is, first of all, it's inevitable.
Yes.
If you're welding, you're gonna have distortion.
Yep.
But we've got parts, a lot of these things that we've been showing here, these things are machined to 1,000. You can't ruin these things.
Yeah.
Everything has to fit up perfectly. One of the techniques that really works for us is if you recognize that the causes of weld distortion are basically how much volume is glowing, all right? The more that glows, more volume that glows, the more distortion you're gonna have.
Yes.
So what we want to do when we weld something up to this, suppose we're putting a cover plate on this thing, is we're going to wrap that whole area in a wet sock, right? We're going to blast it. Usually we compensate with more voltage because we need to get plenty of penetration, plenty of heat, but we need small volume.
Duh, you drop your amperage?
Oh, we go up.
Okay.
We go up. We want to make sure that, with all that heat sink nearby, that we're
Yep.
definitely getting the penetration
Yes.
that we want. And so long story short, or long story long, we really have managed with a lot of these things that are very, very well made to not distort them,
Yeah.
using that technique. And so what you were showing in that video, typical operation we'll do, we'll have a kid, he's got the MIG, he's looking to do a healthy, aggressive 1 second stop, right? Maybe 2 or 3 seconds.
Yep, if you look under his left hand,
And he'll just quench it. It's
Oh.
terrible. It's a terrible thing to do.
It's-
But I think a lot of people who are your viewers know that when you have that precision part, you got to figure out a way to have it still fit up the way it was meant to fit up.
Yep.
And this technique works.
So we always did a piece of aluminum or a non-weldable metal
Right.
to suck all the heat. So I can't tell you how many pieces of brass and aluminum I blast.
So yeah, no, same principle. I mean, this is probably more aggressive, and there's other issues since we're mainly MIGging. That of course the vapor from that water can be a problem.
Yes.
Right? So there's a little bit of a science that we have to make so that the water vapor doesn't mess up your shielding gas.
Okay.
Right?
Which
Because you
is,
can't-
or is it a
It's-
ghost that you can't get rid of?
Nah, it's mostly just a question of you can't get immediately, you can't literally have your weld area wet.
Yes.
Right?
Yeah.
Your weld
Yep.
area still has to be bone dry.
Correct.
Yeah.
Okay. So another thing I always like to ask my guests of whether it be a cutting tool maker, it be a machine maker, or even so are you familiar with Dr. Rohan Prabhu?
Yeah.
He bent my ear for 20 minutes about that. A really, really good challenge. What was your biggest? Have you ever had a gigantic challenge that really tested you?
Certainly the things that we do for the steel bridge competition are a new challenge, every year. They are. What makes them great, what makes them fun is the fact that that the solution to it can't even come from just one smart person.
Right.
A lot of times, I guess I can talk a little bit about just last year, but not
Okay.
too much because it's still related to this year's competition. Is the challenge we had was how do you build a bridge? These bridges that you've seen in the videos and so forth are about 20 feet long. There's a river you can't cross. Last year the river was 16 feet long. So how do you build a bridge without being in a 16-foot gap?
This is the rolling one, right? Where
yeah.
Okay, please go.
Yeah. So what did we do last year? And it was an idea that came from first a spark of one student, but then major contributions from other students along the way to develop an idea that effectively what our team did was to first assemble from tools. We have rules on what is a tool in this competition. So a tool is anything that fits in a 4x6 by 42 inch box.
Okay.
Right, that's a tool. Anything that fits in a 4x6 by 42 box is a tool.
Okay.
So then we use 12 different tools, and we assemble rapidly a temporary beam.
Yes.
A temporary beam with rollers in it. And then we build the bridge on that temporary beam.
Yeah.
Now, it only took maybe 20 seconds for 2 guys to put together 12 of these parts.
I remember watching you do that out in the parking lot.
Right.
That's
And they build the bridge upside down for
Yep.
reasons that, once you really get into it, you realize that the solution to a problem is never you immediately have the right answer. Like, you're going to have a temporary beam. You're going to build a bridge on a temporary beam, but then you got to get the temporary beam out.
Yeah.
So you actually want the temporary beam, when you're all done, to actually be on top rather than on the bottom. Because if it's on top, you can pull it off and run with it.
Yeah.
Right? If it's on the bottom, how the heck do you get it out of there? So you build the bridge upside down, and then you flip it. And it looks like a circus act.
Wow.
Those kinds of things are really an awful lot of fun, because everybody on that team last year really contributed to developing that idea.
So the last thing I'll ask you.
And of course, you
yeah.
guys made many great water-jetted parts for us. And we couldn't have done it without you.
Thank you. Thank you very much. It's a big bonus to the shop here at Engineering.
Oh, yeah.
So that's all of it. That's Chris, Frank, Marvin, and myself.
Everybody.
So the last thing I'll bring up today is you had done this test further down. I think they were rebuilding the parking deck at the time, so you used the entryway to Kirby Field, the overhang.
Oh, yeah.
Remember that team? I think it was under 2 minutes they had that entire damn bridge put together.
We have had a lot of teams
Running like
in the
crazy.
2 or 3 minute range. Yeah, and actually, I don't know if time permits, I did include a video. That was the team that had had gutters. Remember the gutters?
Yes, that's the one. They threw parts down and they had. Was it actual gutter material?
Actual gutters came from my garage.
Yes.
It actually did. I had some extra gutter material, and we used it.
They threw parts down the gutter to the builder.
I've actually got that video.
Oh,
if you wanted
where
to
is
show
it?
That is under, what's it under? Steel Bridge Competition. That is the 2018
Lafayette Builds at Nationals. Got 2 camera views on that. And this is an example. Is the rules
18?
2018.
Yeah.
Let's
2
see if we
views
have
on
it. Let's go for this. We have plenty of time. Oh, what?
So we got 2 views. On the left, what you're seeing is kind of an end view of where these parts are for the steel bridge company.
Yes.
And then on the right, you've got a side view, and blue is that river that you can't cross.
Okay.
Now, the strategy of this team is that, well, you're going to build really quickly if you can get the whole bridge stable as fast as possible. So they bring out these temporary support beams. And that's what's being dropped in right now. On the right, those beams are temporary. Those aren't the actual bridge. It just
Okay.
allows you to stabilize the legs for the bridge and then bring out the gutters.
Ah.
Now, the gutters, and of course I'm proud, because after this, they outlawed all that.
Yeah.
Like, anything you do in this competition that's innovative is going to be illegal, right? And so you're not allowed to do that anymore. And then the purpose of the gutters is that then the guy in the yellow hard hat, his job is just going to be for the next 2 minutes to run. He's going to run back and
I
forth.
remember this.
He's going to drop parts into the gutter, and the
Yeah.
gutter's going to take it across the river. Now, that just saves transportation time. It also has the advantage of the other builder who needs that part is never going to have to wait. There's no coordination between the guy running
Wow.
and the guy who's grabbing parts. So they just drops them in the gutter. There's 2 gutters. He'll just keep filling the gutters, and the guys on the other end are just building that bridge. And I do believe the overall build time on this bridge is probably in the neighborhood of 3 minutes and change.
I mean, think about that. 3 minutes. How many people were on this team?
That build team right there was 4 people.
4 people putting that thing together in 3 minutes and change.
Yeah, yeah. Over a river you can't cross.
You're right.
Right?
That was teamwork.
All the parts are size limited. Every part has to fit in a 4x6 by 42 inch box. Every member has to be bolted. So you got to bolt all that. There's a total of about 44 members on that bridge. All of them have to get bolted up. And so there's a lot going on there.
Oh, man.
But the innovation comes from recognizing that, you know what, if you didn't have that temporary support structure and those gutters, it would be, first of all, harder to stabilize the bridge while you're trying to put it together. And it would always be more, he's dumped the gutters already, right? And it would be always.
And they pull them out of the way.
You pull them out of the way. Yeah, that was an awful lot of fun. And it's a fun thing every year. Like I said, it's like this year we're playing baseball, and next year we're wrestling, and the year after that we're playing a different game. It's a different game every year.
Oh, man. And then now, is this where they'll flip the bridge and take those temporary structures away?
They will. Those temporary guys come out pretty soon, I think. It's one of the last things they do.
So I saw the guy in the yellow hard hat actually step on the proverbial river.
Yeah.
So you can be in it, but you just can't cross it.
That's right.
Okay.
Yeah. Yeah, it's not like NFL football where breaking the plane is not a thing.
Right.
We-
Okay. Oh, darn! Look at that. Just go, go, go. And
Yeah.
this is all with a small team.
Yeah.
Now we have, like I said, we have a fully functional shop.
Our shop is tremendous. It's, we really can't thank you guys enough for what you do for us.
We really try.
We try to not mess it up.
We have a lot of fun. Whenever we see your cart come down the hall, we hear that clanky steel
Ooh.
cart come down the hall. Oh, it's going to be a fun week.
Yeah.
We know it'll keep us busy. This is insanity.
Yeah.
And he threw his. Oh, look at that. Oh, that was excellent. So that that wraps up just everything I wanted to talk about today. I know we kind of veered a little off the path with not everything being sawing, but the Marvel saw and everything you do with it and what you guys in civil
I
do with
think
it.
that's the key is that, you know what, yeah, it is still about sawing because sometimes there are people who do work of the type that we do
Yeah.
where that kind of saw really is instrumental for what we do. It's not for everybody, right? If you're cutting angles to length or something like that, well, you don't need the marble saw.
Correct.
Right? But if you're doing things like what we do, it's a great piece of equipment.
So we wanted, we at Cutting Tool Engineering wanted to take a minute and thank Dr. Kurtz again for coming on the show and spending all this time with us and showing all these little things. One more little demo. Did you still have that section of bridge?
I do. Yeah, this is
This is after the weld.
Yeah. So this is what a section looked like. So I had shown this beautiful guy. That quarter turn connection.
Yep.
And then we see right here. That's that quarter turn right there.
Yep,
You can see
yep.
that. And on the other end,
The T-slot for the
yeah,
lollipop.
we got that T-slot guys right there. And then on the other end, what do we got on that? There's the female,
big monster.
The female end of that quarter turn.
Yep.
On this end, you got that male. And so there's a lot going on in this member, but then you can also see where it bolted.
Yes.
You see right
Yep.
there is where it bolted. On the other end is where it bolted. Now these guys were 3 builders in about 3 minutes and 5 seconds.
Wow.
Over
How long
River
was that
and
bridge?
Kitchen. About 20 feet long. Yeah.
So you can see just
Second place nationals.
the powerhouse that Lafayette is for steel bridge building, along with all of our other engineers. So once again, we want to take the time to thank you for taking all this time with us.
My pleasure.
Talk shop.
Been a great time.
Remember, if you or someone you know has a high schooler looking for a place to put you ahead of the pack, Lafayette Engineering is welcoming you. So please join us. Once again, make sure you tune in, same time, same place next week for the final episode of this month's thing on sawing at the Daily Grind. Thanks, everybody. Bye-bye.